Okay, a few words about lines. So we'll talk about slope, equations of lines, parallel and perpendicular lines, average rate of change, and then piecewise functions at the end. And then at the end of the lecture notes, there are some highlights. So the slope of a line, if you have 2 points, x1 and y1, and x2 and y2, change in y over change in x, as long as the denominator is not 0, because you can't divide by 0. So what's the slope of the line that goes through these 2 points? Well, we can take x1 equal to -2, y1 equals to 1, x2 equals 4, y2 equals 13, and then it will give me 13 minus 1 over 4 minus 2, right? x2 and y2 come from one point, x1 and y1 come from a different point, so it's y2 minus y1, x2 minus x1. And that's 12 over 6, which is 2. You could, of course, do the other way, which is say x1 equals 4, take this point to be x1 and y1, and x2 to be -2, and y2 to be 1. And then your slope is y2 minus y1, which is 1 minus 12, 1 minus 13, over x2 minus x1, which is -2 minus 4. That's minus 12 over -6, which is 2. Those are the same thing. So it doesn't matter which point you take as x1, y1, or x2, y2, the signs will always work out so that you get the right thing. So equations of lines, generally there's 3 different equations for lines. One is the point slope formula, one is the slope intercept formula, and one is the general formula. Point slope equation is this, and this basically comes straight out of the slope equation. If I have a line and I know this particular point with coordinates x1 and y1, if I take any other point xy that's on the plane, then I know the slope m is y minus y1, which is the change in the y coordinates, or x minus x1, which is the change in the x coordinates, right? X minus x1 is this, y minus y1 is that. If I multiply both sides by x minus 1, we get this equation, which is the point slope formula. So I can take either of these 2 points. I'll take the point 4, 13. And I know that m equals 2 because I calculated above. So it gives me y minus 13 equals 2 x minus 4. If we take the other point, which is -2, 1, you get y minus 1 equals 2 times x minus the quantity minus 2, but x minus 2 is x plus 2. So we can write that as y minus 1 equals 2 times x plus 2. So there's 2 different point slope formulas. They're actually the same formula, because when we actually solve for y, we get something called the slope intercept formula, mx plus b. So if we take y minus 13 equals 2 times x minus 4, and we solve this for y, that will give me y minus 13 equals 2x minus 8, and then I add a 13 to both sides, and that gives me plus 5. So if I solve this equation here for y, I get 2x plus 5. If I solve the other equation, y minus 1 equals 2x plus 2, I'll distribute the 2 to get 2x plus 4, and then add the 1 to both sides, get 2x plus 5. We get the same y equals mx plus b formula. So again, it doesn't matter which point you choose in the previous one. When you solve it for the y, you get the slope-intercept equation. What's the x-intercept and what's the y-intercept? X-intercept, set y equal to 0, solve x. right? So we say 0 equals 2x plus 5 minus 5 equals 2x minus 5. And do that for a moment. Minus 5 over 2 equals x. So the x-intercept is x is minus 5 halves, and whenever with the x-intercept, y is 0. For the y-intercept, set x equals 0, solve for y. And with this, it's actually pretty easy. You just get y equals 5. So x is 0, y is 5, is the y-intercept. That's that number. That's the y-coordinate of the y-intercept. So we can graph this actually pretty easily. Right? We know it goes to the point y equals 5, and it goes to the point with x-coordinate minus 5 halves on the x-axis and the y-axis. We also know that if you graph this, if you go 1 unit right, you would go up 2 units because the slope is 2. So that's a way to get another point of the line, and that gives me my graph of my line with its x-intercept and y-axis. So here's a example that's a little bit of a word example. So a company makes golf clubs. To make 50 golf clubs costs them $8,748. To make 90 golf clubs is $10,312. And the relationship between cost and number of golf clubs made is linear. So find a formula giving cost as a function of the number of golf clubs. So this is the input or domain. We usually call that x. If I know how many golf clubs I'm making, can I figure out what the cost? This is my output, which is my range, and we usually call that y. So clubs made, that's x, cost is y. 50 golf clubs cost me $8,748. 90 golf clubs cost $10,312. So I'm going to graph this really kind of vaguely over here somewhere. X, this is clubs made. Y, this is cost in dollars, and 50 and 8,748. That's 1 point on my graph, and 90 and 10,312. It's another point on my graph. And what I want to know is they're saying that the relationship between cost and number of golf clubs made is linear. So these are 2 points on the graph of cost as a function of clubs made, and this should be a line. What I want to know is what's the equation of that line? So how do I do that? I need the slope, and that's the change in y, 10,312 minus 8,748 over the change in x, 90 minus 50. So my slope, which is m, equals 39.1. So once we've found that, we can move to the point slope formula, which is y minus y1 equals m x minus x1. I can take either one of these two as points as x1 and y1, and we'll take this point, y minus 8,748, that's my y, equals m, oops, know what m is, it's 39.1, x minus 50. If I take this and solve for y, that will give me my slope-intercept form. That is, if I actually solve that for y, we get y equals 39.1 x plus 6,748. 93. And you solve this for y by distributing the 39.1 and then adding the 8,748 to both sides. So there's our formula. So if you've got 2 points and you want to know the equation of the line, find the slope first, plug it into the point slope formula, which is this one here, and then solve for y to get the slope intercept formula. So what are the units of slope? So we'll answer that question here. Well, the slope is 10,312 minus 8,748 over 90 minus 50, because that's what this is. These units are all in dollars. These units are in clubs made. How many clubs were made? So the units of slope are always a ratio, this per that. So we get $39.10 per club. It costs them $39.10 to make one club, right? That's what the slope represents here, right? And the units of slope are always units of y per units of x. What is the y-intercept? Y-intercept here so this number here, the 6,793, that is the y-coordinate of the y-intercept, the x-coordinate being 0. So y-coordinates are always measured in dollars. So it's $6,793. Why is this not 0? Well, if x equals 0, making 0 clubs. So what's the 6,793? This is what's called a fixed cost. It's, the running a factory, right? Even if you don't make any clubs, you got to pay the rent, you got to pay the taxes, you got to pay the water bill, you got to pay wages, you got to pay all sorts of stuff. So the 6793 is the fixed cost that they have just because they're running a business, because they have a factory. The 39.1x is a variable cost because that depends on how many golf clubs you make. If you make one golf club, it costs you $39.01. If you make 100, it costs you what, $3,910. So what's the cost for making 100 clubs? It's $3,910 for making the clubs themselves plus 6,793 because that's your fixed cost. So that's interpreting this stuff. So example 6 is above. And so a little bit more about what fixed costs and variables. Oh, actually, I did this. I got a little bit ahead of myself. So fixed cost is a cost that doesn't depend on how many things you make. And variable cost is a cost that does depend on how many things you make. So here's Bob's Donut Store, right? Fixed costs, right? Rent, electricity, wages of about $3,000 a month. Variable costs are 60 cents per donut. They can make 45 donuts a month. So what is the cost function? And the cost function is, I should add that, a monthly cost function because we're asking how much does it cost each month. So the costs depend on how many donuts they make. So y is the cost in dollars, x is the number of donuts, right? So cost depends on donuts. Donuts would be the domain, y would be the cost. So what does it cost? Well, 60 cents per donuts, that's $0.60 times x. make 10 donuts, it costs you $6, plus your fixed costs. Right? So the variable cost is the slope, the fixed cost is the y-intercept. Maximum production of 4,500 donuts per month. So this is the monthly cost function. What's the graph look like? Well, this is X. Donuts made. This is Y. Cost in dollars. So 3,000. And they can only make up to 4,500 donuts. So that's the graph function. The domain is 0 less than or equal to X less than or equal to 4,500, because that's how many donuts they can make. Maximum is 4,500. And of course, we only want integers in there. For ease of representation, we just draw on the line, but really you're not going to make a third of a donut. So I'm clear what that would be. So the domain of the cost function is integers between 0 and 4,500. The range is 3,000 up to 45, whatever the amount is that you would have for 4,500. Desperately for my calculator. So for 4,500, if they make 4,500 donuts, that means it costs them $2,700 to make the donuts, plus 60 cents, plus $3,000. So the range is 3,000 is less than or equal to Y is less than or equal to 5,700. And that's an increment of 60 cents. So I'm not going to actually say that, right? So domain is left and right. In this case, that's how many donuts they can make between 0 and 4,500. And range is the minimum cost, which is 3,000, up to the maximum cost, which is 5,700. Okay, vertical lines and horizontal lines. The point 2, 3. Here's X, here's Y. 1, 2, 1, 2, 3. That's that point. Horizontal line is this. It's got the point 2, 3 on it. Could also have the point 5, 3, minus 2, 3. All the y coordinates are 3. And so this line is y equals 3. And notice that the slope, right, if I take any of these 2 points with the same y coordinate, it's change in y over, say, 5 minus 2. That'll be 0 over 3. That's 0. So the slope of a horizontal line is 0. Vertical line would be something like this. Go through the point 2, 0. Go through the point 2, minus 2. All the points on a vertical line have the same x coordinate. So that's just x equals 2. What's the slope? Well, if I take 2 points, say 2, 3, and 2 minus 2, 3 minus 2 over 2 minus 2, you're dividing by 0, so it's undefined. So vertical lines have an undefined slope. Horizontal lines have slope equal to 0. So if we're thinking about slope, what that means, negative slope means you're going down. 0 slope means you have a horizontal line. Slope 1 is something like that. Since 3 is bigger than 1, a line of slope 3 is steeper than a line of slope 1. And finally, my vertical line has undefined slope. So the last equation for a line is the standard form of the line, which is x plus by plus c equals 0, where a, b, and c are constants. At least one of a and b are not 0, right? And we like this because it's one equation and it's got all the lines in it, including vertical lines. Vertical lines just have b equals 0. So we can sketch these pretty quickly because we can just find the intercepts. So what's the x-intercept of this line? Set y equal to 0. Solve for x. That gives me 2x minus 12 equals 0. X equals 6. What's the y-intercept? Set x equals 0, solve for y. Doesn't matter what function you're dealing with, finding the intercepts is always the same procedure. That gives me 3y minus 12 equals 0. That means y equals 4. So my x-intercept is the point 6, 0. My y-intercept is the point 0, 4. And that makes it actually quite easy to graph. It's going to be a graph like that, where this is x is 6 and this is y is 4. So what's the slope-intercept equation for this? Well, m is actually easy to find, right? Because this is the point 0, 4. This is the point 6, 0. So if we're doing y1 minus y2, x1 minus x2, you can set that up, but it's easier just to see that going down 4 and right 6. So change in y is minus 4, change in x is 6. And we know what the y-intercept is, it's 4. So there's my slope plus my y-intercept. Or if you want to clean that up a little bit, there's my slope-intercept equation line. So parallel lines, if they're not vertical, well, all vertical lines are parallel, but if you have the same slope, then two vertical lines are parallel. So find the slope in equation of a line going through this point and parallel to that line. So what we need to know to find the equation of a line, we need the slope. And if it's parallel to this line, then we want a slope of line 2. And we need a point on the line minus 2, 4. So we use the slope point slope form, which is y minus y1 equals m x minus x1, and that gives me y minus 4, because that's my y coordinate, equals 2x minus 2, 2x plus 2. And so we get that if you distribute this 2, this becomes a 2x plus 4. And we add a 4 to both sides. It gives me y equals 2x plus 8. So it's a line that's parallel to this line because it's got the same slope, and it goes through this point. If you plug in x equals minus 2, you get minus 4 plus 4 equals 4. So that's correct. Two lines are perpendicular if they're right angles to each other. Horizontal and vertical lines are always perpendicular to each other. Remember that their slopes aren't defined. If you have two lines that have non-zero and defined slopes, so neither horizontal nor vertical, the product of the slopes has to be minus 1. So why is this true? Right? M1 times M2, if that's the slopes, is minus 1. So suppose I have a line and it's got a slope M1x plus some y-intercept. I'm not interested in the y-intercept. But M1 means if I pick a point and this is my change in x, this is my change in y, little triangle means change in, M1 is the change in y over the change in x. So a perpendicular line is at 90 degrees. And if I rotate this line here through 90 degrees, what do I get? I should get this new line. But if I rotate this triangle through 90 degrees, what happens? The delta x becomes my change in y, and my delta y becomes my change in x. And now my delta x, this is actually, I'm going right delta y and down delta x, so there's a minus sign. So if this is y equals m2x plus b2, what's my slope? M2 is going to be change is the rise, which is the delta x, but with a minus sign because we're going down, over my delta y, because that's now because I rotated 90 degrees by change in x. So if I take these two and multiply them together, the delta y's cancel out, the delta x's cancel out, but we're left with a minus sign, so -1. So same kind of process here. I want something perpendicular to this. So I want something with a slope m2 times m1 equal to -3. m2, no, sorry. Product of the slopes is -1. So this line has slope -3. I want a line whose slope times m1 is equal to -1. So m2 times -3 to be equal to -1. And if I divide both sides by -3, I get 1/3. The minus signs canceling out. So I want a line with slope m2 equals to 1/3. And the point that I have is 2 minus 1. So we set up our point slope formula, y minus -1 equals 1/3 x minus 2, y plus 1 equals 1/3 x minus 2/3. Subtract 1 from both sides, and you get 1/3 x minus 5/3 is the equation of the line that goes to the point 2 minus 1, and it is perpendicular to the line with slope -3. Okay, finally, average rate of change, not finally, we have average rate of change and then piecewise functions go. So here is the graph of the price of gold per troy ounce in fall 2022, and this is from a website called monex.com. We got dates along the bottom, and you can see what the price of gold is along the right side here. Price in dollars. This is time, right? And that's measured in months, years, days, not entirely clear. So on Monday, 31 October, so if we go to 31 October, we want to know how much was gold selling for. We go up to this point on the graph. We ask what point that is. That point is 31 October is your x coordinate, and your y coordinate is 1638. On January 2nd, gold sold at 1856. So that's here. And we go up to the graph. That's my x coordinate to find my y coordinate. That's actually right at the very end. So Jan 2, 1856. Great. So what was the average rate of change, right? In 2 months, it went from 1638 to 1856. What was the average rate of change per month? So monthly average rate of change. So change in time is 2 months because we go from the end of October, so November, December to the beginning of January, that's 2 months. Change in price, so delta P, is what? Well, it's 1856 minus 1638. 1658, $218. So change in price over change in time is $218 over 2 months. So $109 per month, right? That's the average rate of change. And we look at this, we think this is a slope, right? Delta P over delta T, change in price divided by change in time. It's a slope. Another tip off is that the units here are this per that dollars per month. We could also say, though, if we wanted, what's the daily change on average? Delta T in terms of days is 62. So there's 62 days, and the change in price is still the same, 218. So what's delta P over delta T? 218 over 62, that's dollars. And 218 over 62 is it changed about it's $3.52 dollars per day. Right? So when we look at our graph and we think about a slope, what we did is we took the change in y from here to here and divided by the change in x. So if we draw this line here that connects these 2 points on the graph, the slope is the average rate of change. Right? Take 2 points on a graph, just connect them, that gives you the average rate of change. Why did we get 2 different values? Because it depends on whether you measure this in months or in days. You could do either, right? But the choice of unit there actually changes what the slope is, although the actual change in the price stays the same. So you do have to pay attention to what your units are. So often you'll see problems that just sort of find the average rate of change in this function from here to here. And that means we've got a graph, x squared minus 1. If you graph it, looks, well, it's a parabola, so it looks more or less like that. X equals 2, x equals 5. This is really not to scale. So when x equals 2, y equals 3. So this is the point 2 comma 3. X equals 5. 25 minus 1, y is 24. So this is the point 5 comma 20. So just as we did before, we have a graph. We can connect them with a line. Average rate of change is the slope. So we have 2 points, x and y. One is x equals 2, y equals 3. One is x equals 5, y equals 24. Slope is 24 minus 3 over 5 minus 2, which is 21 over 3, which is 7. And this problem doesn't have any units, but it's units of x per units of y per units of x. Finally, piecewise functions. Some functions have different formulas for different intervals in the domain, and these are called piecewise functions. So here's a piecewise function, right? It says if x is less than 1, use this formula. If x is bigger than or equal to 1, use this formula. So minus 1 is less than 1. So that means we use this formula. And that gives me f of minus 1 is minus 1 plus 1 equals 0. So if I plug minus 1 into this formula, I just get 0 out. F of 2, so that means I'm assuming here that x equals 2. And x is 2, and 2 is greater than 1. We use the formula f of x equals x squared. Because when x is 2, that's bigger than 1. So we look it up there and then we go and say, okay, well, x squared. So f of 2 equals 2 squared equals 4. And f of 1 is a little bit tricky, well, not too tricky, right? It's saying here x equals 1. But 1 actually equals 1. So that means we're using this formula because that's the less than or equal. This is strictly less than. So we have to use f of x equals x squared, and f of 1 equals 1. So if you've got a piecewise function and you want to know what f of x is, you can figure out which of the two formulas you need to use and then use that formula. So what does a graph of this look like? So for x less than 1, we want what? Y equal to x plus 1. And for x greater than or equal to 1, we want the graph of y equals x squared. So we set up our x-axis and y-axis. This is x, this is 1. Y, here's 1. This is x bigger than 1. And to the left of that is x less than 1. So x equals 1 is this dividing line. And on this side, we want the graph of y equals x plus 1. And on this side, we want the graph of y equals x squared. So x plus 1, that slope is 1, y-intercept is 1. That's a line that goes through 1. And it goes out that way. I don't know. I'm going to deal with x equals 1 later. Y equals x squared is a parabola, just opens up. And at x equals 1, y squared is 1. So we just get the half of a parabola. So remember that a parabola looks like this. When x equals 1, y is equal to 1. We just want this side of my parabola. That's my drawing. Now, where do I put my empty and full circles? Where x is greater than or equal to 1, we want y equals x squared. So for 1 itself, we want a filled in circle here. We want an empty circle here because when x is actually equal to 1, we use this formula. So that's that. And that's a graph of a function. So if you have to graph a piecewise function, right, break up the domain at wherever the breaks are and then sketch it. And then there's sort of a list of the various formulas and stuff that we did in there. And so that's lines.